Hey Lawrencium users, today I'm showing you how to connect to Open OnDemand and launch a Jupyter Lab on Lawrencium cluster. This eliminates the need for complex SSH tunneling and makes the cluster computing accessible through your browser. So why wait? Let's dive in. Open OnDemand is a web-based portal for HPC resources where you get a user-friendly interface to run interactive applications like Jupyter Lab, VS Code, Desktop, RStudio, and MATLAB directly on Compute Cluster. In this video, we will see how to log into Open OnDemand portal and launch Jupyter Lab on CPU and GPU partitions. So let's log into Open OnDemand portal. The web address for Open OnDemand portal is lrc-ondemand.ovl.gov. So the step 1 is open your browser and navigate to OOD URL. Step 2 is to log in with your institutional credentials. Open OnDemand uses CI logon for authentication. I'm going to choose Lawrence Berkeley Lab as my home institution or affiliate institution. I can't remember this selection. You can choose another institution if your account is associated with another institution, such as UC Berkeley or any other institution. So let's log on. Entered my password, and now I'm gonna enter my OTP from my authenticator device. And here we go. Here is the dashboard. The key sections on the dashboard are files for file management, jobs for job monitoring, clusters for shell access, interactive apps for launching applications like Jupyter Lab. My interactive session shows you current and past app sessions. The interface is intuitive and eliminates the command line complexity. Let's launch Jupyter Lab. First, we will launch the Jupyter Lab using interactive mode for exploration and debugging. Here is the submission form. The key settings for Jupyter server in the interactive mode are name of the job. So job name of your choice will be entered here. Some project account name. And you can choose the account, project account that is associated with your account. The number of CPU, which I'm choosing 1 for now. Wall clock time, you can choose as per your requirement and keeping it 1 hour. Email address is optional. I have entered specifics to my account. You would use your own choices in the field shown in the form. Let's click launch. Now the job is queued and will start shortly. Let's click connect to Jupyter. And here is the Jupyter Lab session started for us. If we close that Jupyter Lab notebook application, then you can see all the different kernels that you can use. Now let's go back to the web browser. And this time we will use Jupyter Server to launch the session on the compute nodes. And here we will choose CPU partitions to launch the job. Here is the submission form for the Jupyter Server to launch job on the compute nodes. And as you see, form is different and has more fields to fill up. Here I will use Anaconda, the latest version. Extra software module if you wish to load. I'm leaving it blank for now. This is the name of the job. I'm choosing it as OD Jupyter. And here are the partition names listed. I'm going to choose LR6, which is a CPU partition. And I'm going to choose QoS as LR normal. And here is the project associated with my account. Number of nodes, I'm keeping 1. And number of hours, I'm keeping as 1. Email address is again optional. Reservation is really required in very specific cases. And this reservation is the slum reservation. I don't read it at this point, and I'll launch the session. Session is queued, and it will launch shortly. Let's talk a little bit about the partition. So partitions are the group of compute nodes with different characteristics. To learn more about different characteristics of partitions, please visit our documentation page, which is scienceitdocs.lbl.gov. And on here, you can browse to high-performance computing systems. I'll choose CPU cluster. And here are the different partitions with its specifications. Choosing the right partition optimizes the performance and resource allocation. Now our Jupyter Server session is launched. And as you can see, it is on the compute node. Let's connect to Jupyter Notebook here through Jupyter Lab. And here are the available kernels for launching the Jupyter Notebook. Let's go back. In the third example, we will launch this session on the GPU partition. We'll go back again to Interactive App, Jupyter Server for Jupyter Server. Choosing Anaconda. Now I'm choosing the partition as ES1. Select GPU as A40. Number of GPU cards to use. For now, I'm choosing as 1. And I'm choosing GPU, minimal CPUs associated to be associated with the GPU cards to be 2. But every GPU has a different number of CPUs that can be associated with it. Although minimum is 2, there can be more CPUs allocated for each GPU card. Let's go to the GPU node. As you can see, if you request A40 cards, you can ask for 16 CPUs for a GPU card. Here they have chosen 3 GPU cards and 14 CPUs for each GPU card. We can select the same and we can put it as 16. Email address is again optional, and let's launch it. Perfect. All 3 sessions appear in my interactive session. General partition is running. GPU is queued. I'll connect to the running session. So here we have 3 sessions launched. One is on the interactive mode, another is on the CPU partition, and the third one is on the GPU partition. Jupyter runs on the cluster through our browser. You now have access to all compute power and storage of the HPC cluster in familiar Jupyter Lab interface. So now let's go back to some best practices. So here are the quick best practices. Choose partition wisely. Don't waste GPU resources on basic tasks. Be realistic with the time requests. Save work frequently. Because sessions can time out. Monitor resource usage in dashboard and clean up old sessions. There can be common issues which we can discuss here. Say your session is stuck in the queue, try different partition or reduce the resources. You can't connect, then refresh your browser and check session status. If your kernel is dying, usually it's a memory issue. So request more RAM or optimize code. Some more pro tips. You can run multiple sessions simultaneously on different partitions. Use the file manager to upload datasets directly. The terminal app gives you command line access when needed. Remember to delete completed sessions to keep your dashboard clean, and always check which partition matches your computational needs before you launch. That's it. Open OnDemand makes HPC resources accessible through your browser. Connect to dashboard, choose interactive apps, select the right partition for your workload, configure resources, and launch. No more SSH tunneling headaches. If this helped you, smash that like button and subscribe for more HPC tutorials. Questions in the comment and I respond to all of them. Thanks for watching.